Hello students, welcome back to my YouTube channel Data Shah. In today's lecture, we'll be discussing certain more questions of mathematical expectation and variance. In the last lecture, I have discussed the discrete random variable questions. In today's lecture, we'll be talking about continuous random variables. So we have our first question. A random variable capital X has the probability density function, which is defined by the small fx over the interval -1 to 1, half of x plus 1, and elsewhere it is 0. So we need to find out the mean and the variance of x. So in this question, the mean is given by the expected value of x, and for a continuous random variable, it is defined as this. Similarly, when we need to find out the variance, it is e of expectation of x square minus the mean whole square. So I'll just write the mean whole square. So let us start the question. So we know how to find out the expectation of x from minus infinity to infinity, x f x dx. So as this is a continuous random variable, so we always split the interval. So here we'll be splitting it from minus infinity to -1, -1 to 1, and from 1 to infinity. Now, how to decide that what would be the intervals? It is given in the question. According to the question only, you will be deciding it. So here we are given this range -1 to 1 and 0 elsewhere. So this means that the value of the function is only valid in -1 to 1 interval, and it is 0 otherwise. So here fx is 0. Here also fx is 0, as we could see. And the only value of fx is lying in this particular interval from -1 to 1. So what we'll get, we'll be having here minus infinity to -1, x into 0. Substitute the value of fx, that is half of x plus 1, 1 to infinity. So let us calculate. Half will come outside. Open the brackets. That's x squared plus x dx. So when we integrate this, we will get x cube upon 3, and the integral of x would be x squared upon 2. Let us just put the values. For x cube, the limits are 1 and -1. So I'll be taking this as 1 cube, -1 cube. Then for x square again, now as we know, the whole square and the cubes of 1 and -1. So let us quickly just put all the values. We are only left with 4.6, that is 1 upon 3. So that means we are getting the value of the expectation of x, that means the mean, as 1 upon 3. So now to calculate the variance, we need to find out e of x square as well. After that, we can substitute it in the formula. So let us calculate. the expectation of x square. So it is defined by the formula x square into fx. So whatever value you have here, you will see the same multiplied by fx within the integral. So again, we'll be splitting. The rest of the steps remains the same. There is no difference. But the only thing, instead of x, you will be substituting here x square. So again, here it is fx is 0. Here also fx is 0. So substituting the values. Minus 1 to 1. Fx is half x plus 1. So half will come outside because it is a constant. Open the brackets. So this is x cubed plus x squared dx. So I can rewrite this as if x cubed dx plus x squared dx. Just we are solving the integral. So this would be the integral of x cube is x raised to the power 4 upon 4 minus 1 to 1 is the range. Similarly, x square integral is x cube upon 3. Just substitute the values. After calculations, we'll be getting this as again this cancels out. And on solving, we'll be getting this as point 6. That is again 1.3. So thus, the variance that's so here we get the answer as 2 upon 9. So this is how we can calculate the expectation and the variance for a continuous random variable. Let us consider the second question. Let capital F be the distribution function and it is defined by this. If P of x is equal to 3 is given to us as 0, then find the constant value C, the mean of the function random variable and the probability that x is greater than 1. So if in this question distribution function is given, so the first thing that we need to do is find the PDF. So this is the difference between the previous question and in this question. So how to calculate a PDF? We know that fx, the PDF, is the derivative of the CDF. I have already explained this in my previous lectures. If you have not seen the previous lectures, please refer to the playlist, the probability distribution. So this is within the range. So the derivative of cx cube is given by this. The derivative of 1 would be 0. So that means for x greater than 3. And again, 0 is 0. So the derivative of a constant value is 0. And here I have taken the derivative of cx cube as 3cx square. I can rewrite this as now. After calculating the CDF, we move ahead to the first part where we need to find out the constant value C. Now, as fx is a PDF, is a density function, therefore, the summation, mm, therefore, the integral from minus infinity to infinity fx dx has to be equal to 1. So again, we need to split here the interval. How to split the interval? What would be the limits? It is always given in the question. So here we are given that from 0 to 3 only the fx is there, and elsewhere it is 0. So we need to split the interval from minus infinity to 0, 0 to 3, and 3 to infinity. So according to the question, according to this PDF values, fx is 0 in these two intervals. So this would be substituting the value of fx here. Now, as 3 and c both are constant, take it outside. So the integral of x square is x cube upon 3. Because this is a definite integral, we need to apply the limits. A cube minus 0 cube. So this is 27 minus 0. That means C is 1 upon 27. Now let us find out the value of the expectation. Very similar to what we have done in the previous question. By the definition, the expectation of a continuous random variable is defined by this. So again, split the intervals minus infinity to 0, 0 to 3, 3 to infinity. Again here, fx is 0. So we'll get this as from 0 to 3, the value of fx you just need to substitute. So now as we can see that we have already find the value of c here. So what we can do is we can find out the value of fx by substituting the value of c. So in 3cx square, so it would be 3c would be 1 upon 27 x square This would be from 0 to 3, and it is 0 elsewhere. So after calculating, this would be 1 upon 9. So I'll just put the value here as 1 upon 9 into x squared. So when I'll be substituting the value here, so instead of 3c, I'll be just writing here 1 upon 9 into x squared. Now, as 1 upon 9 is a constant, this would be x cubed dx. The value of the integral x cube is this. Is 9 upon 4. And that is the e of x is given by 9 upon 4. Now we have the last section part in which we need to find out the probability of x greater than 1. This means you need to find out the probability from the range 1 up till infinity. So this would be given by this formula. Again, in this, because we are talking about 1 to infinity, so 3 is still there. So we'll be splitting the interval. And your fx is 0. So substitute the values. Now in fx, I'll be writing the value of fx, which I have calculated here. So it would be x square upon 9 dx plus e to infinity 0 dx. So this would be x square. So the integral of x square is x cubed by 3. You get this as 1 upon 27. 27 minus 1, that is 26 upon 27. So the value of the probability of x greater than 1 is given by 26 upon 27. So like this, we can solve the questions for the expectation and the variance. So do like and share my videos, and subscribe to my YouTube channel if you have not done yet. Hit the bell icon for the notifications of the new videos, and we'll meet in the next lecture.